Welcome to Arid Online Academy. In this video, we are going to consider strong bases and weak bases. So our focus will be to differentiate between the strength of bases and looking into the factors responsible for these differences. So by the end of this lesson, you'll be able to describe the meaning of weak and strong bases. So let's start first by looking at or recalling what makes a base a base. Remember that a base, is a substance that produces, bases produce hydroxide ion in solution. Alkaline, if you like, produce hydroxide ion in solution. And we have also defined earlier a base as a proton acceptor. But in this concept of strength of bases, we'll look at a base as a substance that produces hydroxide ion in solution. Therefore, if what makes a base is the fact that if a base ionizes, if a base produces ion, or if a base dissociates in solution to form ion, that is the meaning of the term ionization. If a base ionizes, it's going to produce the metallic positive ion or the ammonium ion and the hydroxide ion. The hydroxide ion is going to produce the hydroxide ion in solution. Therefore, the strength of this base is dependent on the extent to which the base can produce this hydroxide ion in solution. If this base cannot produce as much hydroxide ion in solution, it means that the concentration of hydroxide ion in solution would be lesser than if the base could release all the hydroxide present here and put it in the solution. Now let's simplify it further. Let's assume that I have 10 moles of sodium hydroxide here. If I see my base as a pair of slippers, if I could split it into two, if I have 10 moles of slippers, when I split it into two, I would expect to get 10 mole of the right leg and 10 mole of the left leg. The same thing here. If this base will completely release all the hydroxide it has, then I would expect to have 10 moles of sodium ion and 10 moles of hydroxide ion. If this was the case, then I would be able to say that this sodium hydroxide is a strong base. Therefore, we can define a strong base as one that completely ionizes in solution. A strong base completely ionizes in solution. What that simply means is that all the ions will completely separate. All the ions will completely separate. So let me make it more pictorial. If I have two sodium hydroxide molecule, in water, if all the ions will completely separate or completely ionize, therefore, I would expect to get two sodium ion in solution and two hydroxide ion in solution. So if this happens, then the sodium hydroxide is a strong base. So a strong base is one that completely ionizes in solution. Now, let's look at a weak base. What makes a base a weak base? So let's look at this, a weak base. In the same vein, a weak base is one that ionizes partially in in solution. A weak base ionizes partially in solution. So the partial ionization simply means that not all the hydroxide ion available would be separated. Not all available will be separated. Let's take example of a weak base here. Let's take ammonia. Ammonia is a weak base. When ammonia dissolve in water, ammonia ionizes into hydroxide ion and ammonium ion. It's good that you differentiate. Remember, ammonia, ammonium, they are two different species. So in this case, what makes this ammonia a weak base? If this ammonia has a capacity, for example, to produce 10 moles, okay, to produce 10 moles of hydroxide, and it end up producing 2 moles of hydroxide in solution. That means that 8 moles remain inseparable, remains unseparated. So it remains here, while only 2 will be in what? In the solution. Then we'll say that this is a what? A weak base. And if it is a weak base, it means that the concentration of hydrogen ion would be lower. And if the concentration of hydrogen ion is lower, you will know that the pH will be what? Will be low. Okay, if the concentration of the hydroxide ion is lower, the pH would be lower. If the concentration of hydroxide ion is higher, the pH will be what? Will be higher. So let's relate the strength of the base to the pH and what? And concentration of base. So let's relate the strength to pH. So now we are looking at strength, pH, and of course concentration. This is very interesting. So strong base, it is strong. My arrow goes up. Strong base, we have more hydroxide ion concentration, and that simply means that the pH will be higher. Remember your pH scale. This is higher pH, and this is where your alkaline is. This is lower pH, and this is where your what? Acid is. So the higher the pH, the more the alkalinity. Okay, so it's important you get this in perspective and not mix things up. So what are the points that we can recall from here? At the same pH or at the same concentration, if you are comparing two solutions of alkaline, you want to know which one is strong, which one is weak. At the same concentration, the stronger base will have the higher, the stronger base will have the higher pH. Very important to summarize it that way. Then at the same concentration, the stronger base will be the better conductor of electricity, the better conductor of electricity. Now, what makes a substance a conductor? A substance is a conductor because it has mobile ions. So if a solution dissociates completely, that means you have more mobile ions. So the more the mobile ions, the more the electrical what? Conductivity. So the higher the strength of the acid, the higher the what? The ions available, and the stronger the what? The conductivity. That is very simple to note. So let's do a quick summary of what we have learned so far. So we have learned so far that a strong base dissociate what? Completely, totally. Okay, we also learned that a weak base dissociate what? partially, partially. Okay, we also learned that the higher the hydrogen ion concentration, the higher the what? The pH of the solution. And the lower the hydrogen ion concentration, okay, the lower the hydrogen ion concentration, the lower the what? The pH of the solution. Okay, so at the same concentration, the strong base, will be a what? A better conductor of electricity. That is very interesting to note. I'll see you in the next video where we're going to describe the properties of acid and what? And bases. Subscribe to my channel and click the notification icon so that when I drop videos like this, you'll be the first to be notified. See you.